Thank you. Yeah, my name is Katja Hogendoorn. If you wonder, it's Dutch. I came here in 1996 and I was already studying native bees back in the Netherlands. And here I started off studying social systems of native bees, but then moved into crop pollination, which also includes honeybees. Now, honeybees are very important in crop pollination, and so here I have but I've worked in a range of crops, most lately the last 5 years in apple, mainly in netted apple orchards, and how we can improve the situation for honeybees there, and how can we make best use of our honeybees on the net. But also on blue-banded bees in lucerne and on tomato, and native bees in apples, and using honeybees to distribute beneficial antifungals to flowers is another one of those things I've been working on a fair bit. So vegetable crops which are often pollinated, such as carrot, by flies and beetles. So crop pollination in this country and in most countries largely depend on honeybees, but in this country more so than in many other countries, because all our crops are introduced. So all our native bees have not evolved with any of our crops, right? And that is why honeybees are so very important in this country for crop pollination, especially for almonds, because they flower when it's still very cold, and so our native bees wake up when it gets to about 20 degrees. So almond, apple, berries, pear, cherry, lucerne, pumpkin, watermelon and zucchini are the ones that rely for about 100% on pollination, most of them by native bees, and macadamias are there as well, but I selected the crops that are. And of course, a large part of my talk is going to be about Varroa mite, because that is the big news in in the honeybee world. And so Varroa mite was always going to come to Australia, and we all knew that basically. Several incursions have been intercepted earlier, and an invasion was inevitable. And what happened in June, they were discovered near Newcastle, and people searched and searched and searched and found more and more, and then started to eradicate, and they weren't searching very much anymore. And then they found more and started to search again, and at some point they said, well, it's out of hand now, I'm sorry. And you can't really see the specks here on this map, but it's about 200 something kilometers from our border. It will get to us, and that's the reality of it. But it's nearly everywhere in the world. What happened was in the early 1900s, this mite jumped from Apis cerana, which is another honeybee species, to Apis mellifera. And Apis mellifera didn't really have a good defense against it, but it happened in an area where there wasn't a lot of transport of honeybees. And so it came around very, very slowly initially. In the 70s, 80s, it ended up in Europe, and I was there and was already studying bees, so I was well aware of what was happening. In the early 80s, it arrived in the US. In the 70s, it arrived in South America. So the whole world has a lot of experience with this bee, right? Okay. So, despite that, California is still the largest almond grower in the world. So we can live with it. Now, it is difficult to manage the spread for several reasons. One is the bees are free-flying. The mite is contagious. It jumps over on other bees, on flowers. Bees, especially in the almonds, make mistakes to which hives they go, and also feral bees will come in, and they have no beekeeper to control this mite, so that mixes. Beekeepers move hives for honey production and for pollination, and that means that there's infestation of new areas. They can take it back to other areas. It's unavoidable because it's part of the industry. And then there are stowaway swarms that we don't detect and will put themselves on a boat and end up in Western Australia or something like that. So there's lots of ways for these mites to travel along, and that's why they say, well, the mite in itself without help would spread 5 kilometers per year, so we'll get here anyway, but in reality it spreads at the speed of the truck. Now, why is it so harmful? Yeah, untreated hives will die within about 3 years. And the mite feeds on fat bodies that affects the immune system of the bees. It reproduces in brood cells, only of honeybees, so other bees will not be influenced that way, and spreads via flowers. But that's all not why it is so harmful. The harmful thing is that the mite is an incubator and a vector of already existing honeybee viruses. So what happens is a mite will ingest a fat body, will ingest a virus, then will multiply the virus, and when it goes to suck on another bee, it will infect that bee with much more virus and more potent virus, because normally bees get viruses in through their food and they have good defenses in their gut against that. But those defenses are not there when you actually insert it straight into their body, right? So that is where the issue, the main issue comes from, and that is why hives will die. Now, one of the main viruses is deformed wing virus worldwide. And the funny thing is, the mites that came here and the swarm that came here with the mites apparently didn't bring deformed wing virus with it. So we've got lots of other viruses of honeybees, but that one, I'm not sure that we have it yet. So we don't know what will happen. We know that they distribute other viruses that we do have, and that hives will die much more readily of those viruses in combination with Varroa, but that deformed wing virus lingers on and on and on overseas, and if we haven't got it yet, it might be a different story. Anyway, we can have a look at what happened in the rest of the world to hive numbers to understand what will happen to us with hive numbers. So what we see is, this is 1961, this is 2021, and in that period where the mites conquered the world, hive numbers doubled worldwide. So there wasn't really much of an impact on hive numbers there. There is a little dip here. That dip is caused by a change in the subsidies in Russia, right? Because Russia changed their subsidies, so people went away from keeping honeybees. And that had a big influence. Yeah. So hive numbers doubled, so that's hopeful. There's no real reason giving this, and we will see an extra example to think that we will suffer a big reduction in numbers of hives. And of course, given the fact that this has been around since the early 80s, the rest of the world has built up a wealth of knowledge about how to deal with this mite. And we profit from that, being the last one in the line. So this pyramid looks really like what Lizzie Lowe presented. What we have is we can reduce the reproduction with cultural measures, we can, the mite prefers drone brood, so we can put in drone frames and get them out before it emerges and then attract a lot of bees out. We can kill by physical means that is shakes and other ways. We have soft chemicals that we can use, and we have hard chemicals that we have to use carefully to prevent resistance. But all that has been worked out in other countries, and successfully so, because we know that they manage their pollination fairly well. So what will happen to the beekeeping industry then? That's another story. So small beekeepers will leave the industry. Large beekeepers will grow larger, right? Okay, the numbers of hives, as we already saw, will be stable or can grow. This is what happened in New Zealand. Here you have the number of hives. This is when Varroa came in. So they remained stable and then went up big time. The number of beekeepers, as you see, went down, not with the number of hives, because the small beekeepers left the system, and then they grew again. And that's all to do with honey prices and the arrival of Manuka in New Zealand and all those kinds of other market things. So it's nothing to do with the mite at all. Okay, so that is, I think, a very easy way of thinking about it. I don't think that this will have an enormous impact on pollination for horticultural crops, really, apart from one thing. There won't be a shortage of hives of pollination. Okay, this is not. There won't be a shortage of hives of pollination in Australia. Almonds at the moment use about 280,000 hives. That's much more than the number of other crops. The number of commercial beehives in Australia are more than 500,000. 80% of the income of beekeepers at the moment is from honey. Nature pays for that, basically. About 20% is from pollination. That's not much. That balance will change a bit. They will get more income from pollination and a bit less from honey. So no shortage of hives, but there will be increased costs because there is more hive maintenance, and that is real. The beekeepers will have to open their hives several times and treat them and monitor them and change the preparations for winter so that they will survive. There will be a higher demand, and that is very specific for Australia because we have got a lot of feral honeybees. Now, in an almond orchard, as we saw this morning, feral honeybees won't do very much at all. They rely on the managed hives. But in an apple orchard in the Adelaide Hills, most of the growers don't even put honeybees there. The bees in the trees will do it. And that is a different story because those bees in the trees might be gone. They haven't got a beekeeper to take care of them. So they'll be not completely gone, but they'll be rare. Now, this is bad for those apple growers. It might not be so bad for nature, really, because those feral honeybees have an enormous density in some areas, including the Adelaide Hills, and have enormous pressure on native birds, on mammals, and on insects, because they accumulate an enormous amount of nectar and pollen compared to solitary bees and other insects. They are not, like many other insects, food for birds. Noisy miners eat them now and then, but other birds like woolly wagtails and other insect-eating birds, they avoid them because of the stings, so they won't eat them. So it might change something to the better for nature, let's say that. But anyway, these two factors will cause hive lease costs to increase. That will be inevitable. Now, ABIC, which is the honeybee industry organisation in Australia, they have predicted that that would be about a 30% increase. I'm not sure what it's based on. In New Zealand, initially it was a 300% increase, but that came down very, very quickly. And the reason for that is that, well, you get to manage, you can manage hives if you need to, and a 300% increase would cause most horticulturalists that depends on bees to start investing big time themselves. But so a 30% increase, possibly. Hives have already become very expensive, $200, but that depends on the industry. They're most expensive for almonds. They're a lot less expensive for lucerne because their honey is made as well. So it becomes a different ballgame. Okay, that is it. So what can growers do in this context then? Well, what they would normally do, have a good rapport with your beekeeper. That's really important. And that involves having a pollination agreement, because a pollination agreement takes any conflict out of the situation. Both parties know what they can expect. So that is important. Provide clean water for the bees and actually do it and not forget it. Spray at night and not in the daytime when your bees are in the orchard. And don't spray anything that has residual toxicity, because beekeepers get very upset when they come back to hives that are greatly diminished or dead. So that is very simple. And then there are other things, possible things, such as plantings for honeybees, or maintain native pollinators, or there are mixes generally of things to do. And I'll go and talk a little bit about plantings in the interrow, complementary crops, native vegetation, and the importance of native pollinators. So do that. So I did a study in Amaru, Select Harvests, and I looked at 5 blocks with and 5 blocks without weeds in the interrow, and those weeds were flowering when the almonds were flowering, and my question was, does this do anything for the visitation to the almonds? Because it might be competition or not. Does it do anything for the types and amounts of pollen brought back, almond pollen and also other species of pollen? With, in the back of my mind, would it be better for hive health in this situation? And does it do anything for the set of almonds? So we compared those. We had 2 hives at each site, and those hives had a pollen trap on them. Now, a pollen trap is a thing where bees go through, and then the pollen is scraped off their legs and falls into a tray. You take the tray home and you look at the pollen and you say, okay, this and this and this is almond pollen and this is not almond pollen. What type of pollen is it then? Well, we went to all the flowers and harvested all the pollen from the different species so we could recognize it. And so we looked at that. Okay, now, these are different times I visited the orchard. And the blue ones are blocks with, and the red ones are blocks without weeds in the interrow. And this is how many bees were visiting the almonds, and that is very temperature dependent. And you don't always have it under control. So in some cases, I see 4 bees per 30 seconds per tree, and these are averages, in other cases 10 or something like that. But we did it with 2 people, and we did it repeatedly. So what we found was that really it makes no difference whether you have weeds or not in the interrow for honeybees visiting almonds. Okay, that's one thing. Then we looked at the amount of almond pollen collected. And we had 3 dates where we collected the almond pollen because in the first dates our traps didn't work properly. And it varied, but we didn't find any structural differences between the rows with and without weeds in them. And we also looked at the number of pollen species collected. Well, it was largely 1 or 2 because all those bees go to almonds. Almond pollen is marvelously attractive, and really they don't like the nectar as much, but they do love the pollen, And so they went for it. And honeybees have got this recruitment system. So as soon as several come in saying, oh, almonds, the rest will follow. Yeah. So that is, so weeds in the interrow didn't make any difference in the amount of pollen collected, so probably also not in pollination. And probably also it doesn't improve hive health to have them there because they're not collecting more types of pollen. Okay. And then we looked at sets in the rows with and without weed. We had counted all the flowers in branches and then counted all the nuts in the same branch. And there was no difference. So, weeds in the interrow in almonds, I don't think it works. But there might be other things that do work. Okay. There's a conclusion which we have already reached. So weeds in the interrow don't improve bee activity or almond pollination and are unlikely to improve hive health. But it's very dark under row in an almond orchard. And so the bees really didn't go to those weeds very much. Those weeds didn't flower very well either. And as I said, almonds are very attractive to honeybees. And I measured only pollination. I didn't measure any effect of on beneficials. And it might be that there is a big effect on beneficials. We need to know these things. And it can and is different for other crops and other situations, because in apple, having food under trees or in the interrow helps specifically if you have it there when the apple is not in flower. And I'll come to that later. So for almonds, I don't think it makes sense. For apples, it might. And so what we can also do is have productive crops that can support honeybees. So almond orchards have a lot of exclusion zones often, and native remnant vegetation that is degraded and can be improved. And the whole situation here is set up to take care of trees. So they can take care of other trees as well. And so when a rapport with the beekeepers is important, you might think that some of those open areas could be used to produce Manuka honey. So this is a very high valued type of honey, medicinal honey, that it flowers in summer. So there's no relation with almond pollination at all, but it can be beneficial for some of the beekeepers. So that is one of the ideas. But you can also think of complementary crops that flower at the same time. For instance, if you grow lucerne, which only provides honeybees with nectar, you can think of hemp. Now, hemp is a wind pollinator. It doesn't produce nectar, but it produces pollen that is very much loved by honeybees. It's one of their favorites. So the combination might work well.
Can I just ask if the bees are attracted to the pollen by smell or sight? How do they get to the pollen?
Bees are largely attracted by smell. So many people think that colors are important, but colors are important to in fairly close proximity. Smells are the most important thing that bees respond to. Yeah. So, and specifically smell of pollen. So I've been working with vegetable industries, and what vegetable industries do is they want to breed hybrid lines, right? So they've got a fertile line and a male sterile line. And they want bees to go from this fertile line, deliver the pollen to the male sterile line to produce something that is replicable, that they can sell, that no grower can breed from. But their main thing is that they can predict what the attributes of the crop will be. Okay. Now, but they take away the pollen. So they take away the attractor. And so they struggle to get bees going from the fertile to the male sterile line. And that's because the bees can't smell the pollen. Yeah.
Just wondering about the quality of the pollen in terms of the food quality for the bees. Do they go for higher protein content or particular kinds of?
Yes, the quality of pollen matters really very much, and they like unsaturated fats. That is the main thing that they like about pollen. Pollen has got a fat coating around it, and if there's a lot of unsaturated fats, those pollens are generally preferred. So hemp is a really preferred one, canola is a really preferred one, almonds is really good, apple is not so good. Within the eucalypt there is a variety, and that varies enormously. Yeah. So another combination would of course be leptospermum and hemp. Hemp also flowers in summer, like lucerne, or lucerne you plant when it flowers. But that is also nectar and pollen.
So I've just planted about 1,000 woolly tea trees and prickly tea trees in the creek
Yeah.
near the hive.
Yeah.
So that was good.
Yes, you'll get nectar.
100 dope plants as well.
Yes, you call them dope plants, but they might be just hemp seed is very valuable as I mean $30 per kilo, the hemp seeds that are just in the supermarket, not dopey, is yeah. And then you've got complementary native flowers, of course, flowering at the same time. And for here, almond is a big pollen attractant. White mallee, the bees don't like that pollen, so they get nectar from it. So that is a nice combination and a nice one to have in your revegetation. Okay. So then you can think of, okay, well, do revegging around the orchard or around my block or whatever. So if you would reveg for almonds, there are very few other pollinators in almonds, really very few, disappointingly few. At the end of the almond season, I saw some furrow bees coming out, but they were mainly on the weeds, not so much on. But one of the advantages is very often when the bees come into the almonds, you get a cold spell or it gets cold and the almonds aren't flowering well yet. And if you have something then for them, for all okay, something that you mow off if you're concerned about competition, then you might keep the bees active. Because otherwise, if they cannot find anything to eat and it is a bit cold, they might go back to sleep. And that is not advantageous for almond growers. So that is where planting things can help. For apples and lucerne, well, I found 17 species of native bees and many other pollinators visiting those crops. They flower a bit later. And so by that time, a lot of bees are active and temperatures go over 20 degrees. So we have native bees there. And for them, we can plant in the interrow and also around the orchard. So I'll talk a bit about lucerne. So in general, what has been shown is that bee abundance increases with the percentage of woody vegetation within 200 meters of any crop, right? This is a general find. It's what we find everywhere. And having a good bee abundance or insect abundance is fantastic because they interact with each other and they bump each other off flowers, and so you get better pollination because of that. Now Scott Groom, he worked for me for a while, and he looked at, well, here's a lucerne field, here's a lucerne field. How is the set in that lucerne field, and how is the bee abundance in that lucerne field going into it? And very briefly what we found, so we did pod set. We didn't look at seeds, we should have, but we looked only at the number of pods, unfortunately. And what we found was that when you look at the average set in a field, what you see is closer to the edge, you have got about an 8% increase in set compared to going further into the field. Of course, it goes lower than the average because this is the average, but that makes a real difference. So what we can say is edges have got negative impacts on plants as well. You can nearly see that here, but they also have positive impacts. And so we have to study the system further to work that out. But we found, I'm not going to show it, we found the same for bee species going into the field. They're really related to having that edge present where they can get their food at other times of the year and where they nest. Good. Now, what plants do you plant? There's lots of plants that these bees visit. I'm not going to tell you about that. But there are several guidelines. What you need to understand what is when do these bees need food? And very many of these bees were furrow bees. And a typical furrow bee life cycle is these animals overwinter in spring. They have a nest in the ground. It can be an apartment building underground with one entrance, and very many bees living down there doing their own solitary thing, reproducing. So they collect pollen and nectar, put an egg on it, close a little earthen cell, and do that over and over again with many together. And then by mid-spring or late spring, the new generation comes out. And the new generation will again provision cells. So needs pollen, needs nectar. And then in midsummer, the next generation comes out, and the females and males need to gorge on pollen and nectar to survive the winter. So basically, you have a situation where you need food half of the year. Yeah. So when you do this for honeybees and feral bees, feral honeybees are still in the mix for us. Blue-banded bees, they start in end of spring, October. But they are there until April, and they are important pollinators for lucerne. Not so much for apple, I don't see them that much. Nomia bees, important for apple and lucerne. Resin bees for lucerne. What you see is, well, you've got a bit of autumn and winter where maybe you don't need to provide that much. Okay, so nearly year round we need food because bees need to provision their brood cells. And then what kind of food? Well, local native species of plants are best. Why? Because the local native bees have co-evolved with them, they know how to handle them, and we're not only doing something for the bees that pollinate our crops, we're doing something for all bees and all insects and all other species. So you've got a local native plants pool. Is it a resource for bees? We've put things out there already. Watch the Ween Bee Foundation. They put guidelines out there for what is useful food for bees. And the Ween Bee Foundation, W-H-E-E-N Foundation, they're a honeybee organization that puts out guidelines, and they are spreading over the country. So they've got a couple out for South Australia now. They've got Victoria nearly covered, New South Wales, they're busy. They're spreading out with guidelines for local native species for bees. Look at the flowering time, have something flowering year round. Does it suit there? Because not everything suits everywhere, of course. So it's a whole process. Can we grow it? Well, that's important, because if we don't know how to harvest the seed or grow the seed, and this happens, then it's not useful for us anyway. And then, does it not compete with the crop? Those are all the considerations when it comes to plantings for pollinators. Not for general insects, not for bees, not for beneficials, but for pollinators, yes. But we need to do that, because we know there is not enough food in the landscape for bees. And especially during the 2018 and 19 years, my eyes opened to this, because the beekeepers were complaining about eucalypts flowering, but not producing nectar. They couldn't make honey. And the blue-banded bees, they plummeted. I got phone calls from people, because I'm a blue-banded bee specialist. Where are my blue-banded bees? Yeah, well, I didn't realize it back then, but I do realize it now. Now I've seen them come back a bit, not fully in Adelaide, but come back a bit. How damaging those droughts are, especially heat waves in spring. Everything turns to a crisp, and there's no food in the landscape anymore for bees and other insects that depend on nectar, because all flying insects depend on nectar. Anyway, Degradia worldwide is a country as big as Russia. It's not sustainable in the long run, so we all need to start doing this. And what it says, what the Department of Environment has said, is healthy ecosystems need 30% of the land covered by native vegetation. That will be a hard slog for us, but we need to do it. And healthy crop pollination requires food sources for bees, because those bees need to be maintained during the other times. So that is also what needs to happen. And it's not only for bees, because of course we've seen the beneficials, the parasitic wasps, the ladybirds, the damsel bugs and the cryptolamus and everything they eat, and birds. Birds eat insects, by and large. So insects are 80% of all species. Right? 80% of all species are insects. The average species is not a human, it's a beetle. And so that bulk of individuals supports all that life and supports us in the end. So all flying insects need nectar, most eat pollen, and so we need flowers. And birds eat insects and need a place to nest, so more flowers and trees and shrubberies are needed. But there are also more benefits. Shelter for sheep increases survival of lambs and wool production and live weight of sheep, and that is really important. Yeah. And of course, native vegetation prevents erosion, prevents soil salinity, provides fire breaks, and those benefits need to be quantified better, but also subsidies will probably be needed to get to that 30% native vegetation. It's in the interest of us all, so that's what we need to do. And so the question, is it cost effective, doesn't really cover it. It needs to happen anyway. Okay, so I've been supported by a lot of organizations and people in different projects that I've touched on here, and I thank you very much for inviting me, and I love talking about these things.